So, as you saw at the end of the last video, things hadn't gone well. If you looked past the Patreon thank you scroll at the end, I put a little clip in showing that I think I found a solution. After I turned off the cameras, I think it was that evening or the next morning, some of the folks in Patreon were like, oh, this is probably not catastrophic. Check to see if there is a QFN, quad flat pack, no leads. QFN, N for no leads. Ultra fine something QFN. Tiny part. For somebody who's never surface mounted before, my little oopsie is making me dive into the deep end because this is probably one of the harder things to solder. At least I think it is. It's one of the finest pitch things to solder. But at least it means my boards aren't garbage yet. I still have to successfully solder it on. Let me show you what I had to do to get back in the game. So this program is STM32CubeMX. It's the program you use to configure the MCUs. I noticed a couple times I used the term CPU when I was talking about the MCU. I know the difference. If I say CPU, please understand I'm talking about MCU in this context. What you're seeing here is the configuration I made before I started laying out the circuit board. And you go through and you set what all of the pins do. So I've got, for example, here's pin 1, which is PB9, which I've got configured to be board I2C STA. But I can also configure it to be the CAN bus transmit. I could make it the infrared output, the second SPI channel, NSS, whatever that is, a couple of different timer channels, different USART, RS-232 stuff. All the pins can do certain things. Now, it's not the case that any pin can do any role. Only certain pins can do certain roles. I was like, okay, maybe there's a chance here, but I had to come through and configure to make sure that the pins matched. Otherwise, the traces that are built onto the circuit board wouldn't work. Thankfully, STM is pretty good about compatibility. Let me actually back off and I'll show you what you start with. I'm not going to go through the configuration process, I just want to show you what you start with. So this is how the MCU starts. Why does it always close this? I don't know, but it does. You can see how, except for the VDD, which is the plus 3.3 volts, and the VSS, which is the ground, all of the pins are sitting here free, and you can use them however you want. So again, I'm not going to do the whole thing, but to give you an idea, under connectivity, I know that I need a CAN port for the NMEA 2000, so if I click activated, you see how it defaults to a couple of pins. Well, here you can see that it's FD CAN TX, but in the configuration I had before, this was the default, I actually had it as the I2C, the first I2C SDA. Now it's orange right here because I haven't set up the SCL pin, but you can see how the pins can be reconfigured. I had to go through the full configuration for the relay unit and for the compass rose and for the battery display. I had to make sure that all three could have their pins configured the same way to know that my boards aren't garbage yet. There are still plenty of opportunities for mistakes to make these boards useless, but had I not been able to get the MCU to work, 3 of my 4 boards would have been garbage right out of this gate. I know these boards are not going to be perfect and I'm probably going to have to do them again, but I wanted to get through as much of the different components as possible so that I could see all of my issues, set up bodge wires if I have to, cut traces if I have to, but for the majority, just get as close as I can to a finished board so that when I do the next version, as many of the oopsies can be fixed so that there's a better chance my second boards will actually work. Had the MCU been a done deal like I thought it was at the end of the last video, that means that I would have had to go through the expense and time of ordering new PCBs, knowing full well there was probably still issues to be found that I hadn't found yet. So, let me show you the difference when you go to configure the quad flat pack, or quad flat pack, no, whatever, QFN. I'm just going to call it the QFN. So here I go to File, Load Project, where is it? This one here. So I'll take a clip from the previous one and put them side by side, something I can't do in the actual screen here, but you can see how all of the pins were configured exactly as they were on the other package. This is when I knew I was back in the game. Before I get started trying to solder the MCU, let me address some of the common themes in the comments of the last video. First, the vast majority of them were encouraging and helpful in offering advice. Thank you. Genuinely thank you. One of the single best things that has come out for me in starting this channel has been the encouragement and the advice that I don't know how I would have ever had otherwise. It is one of the... I never started YouTube to make money or do anything like that. I just wanted to document the process and hopefully encourage some people. It was a very pleasant and unexpected surprise to get so much amazing, wonderful help. So, with that said, let me address a few of the specific themes and why I'm taking some and not some other advice. Probably one of the most common feedbacks I got was use leaded solder. I understand that leaded solder is way easier to use. One of the single biggest reasons I wanted to make these boards and write the firmware and do all of this stuff now while I'm here on land and things are safe is to build up the skills so that if something breaks out in the field, consider the worst case scenario because Murphy's a bitch and of course that's when things are going to break. I'm on a rough passage, it's in the middle of a storm, which makes sense because if the boat's slamming and something's close to failing, that's likely when it's going to fail. I'm in a really shit situation and I just need to get something fixed and I can only work with what I have on hand. If I learned how to solder lead free, which is the more difficult and the more challenging skill to learn, and I have leaded solder on hand, I'm golden, I'm good. On the other hand, if I learn from the beginning to solder with lead solder, and that's what I get used to, and then later on I have to fix something, and the only thing I have access to is unleaded solder. Oh, sounds like I'm an old person driving an old car. If the only thing I have is lead-free solder, if I'm not used to soldering with lead-free solder, I'm gonna have a really hard time fixing things at that time. It's kind of like learning to drive stick shift. If you can learn to drive stick shift, you can drive an automatic. But if you learn to drive an automatic, you don't necessarily know how to drive a stick shift. It's kind of the same mentality here. So that's that one. Second one that I got a lot was that the chisel tip is too wide. I agree, and I got 5 very fine tip soldering iron tips. However, the solder paste has been working, but this kind of goes against what I was just saying about learning how to hand solder versus I might only have a soldering iron and some lead-free solder and I have to fix it. So that's an argument for me to go back to using hand soldering for more of the surface mount parts as I build these boards. The air solder with the solder paste is so damn useful. I have to be careful not to let that spoil me. I need to develop the skills to do it with just this. The next thing I wanted to talk about was the Flux. I had a lot of folks saying that this stuff was sizzling and probably wasn't doing a very good job. Now, my understanding is that Chipquik is a pretty reputable company, and I'm using MG Chemical solder. I've got 2 types of solder, not just the finer pitch, but of the normal size wire. One has a rosin core and the other one has no rosin core. I was using the one with rosin core in the last video. So I'm going to try to mix that up. Again, not on camera, but I'm going to be experimenting with these different things to figure out what works for me. In this one, I'm probably for the QFN package going to stick with what I know because the package itself is going to be a thing to learn and I would rather keep as few variables up in the air as possible. One of the other things that came up on the Discord, this damn plunger issue I had. When I was trying to solve the problem, and I was chatting with some of the folks on Discord, a couple of them had the same tube, and they were noticing that the one I got had a gray cap on it, and theirs all had a black cap. Apparently DigiKey, when you order the kit, assembles it themselves, and they might have put the wrong tip on this. So, I ordered just the replacement that had the black tip. They sold it by itself, I don't know why. So let's see if that actually fixes the problem before we get started with soldering. Okay, it's all the way in. It backed off a little bit, but it hasn't ejected all of the way yet. Now that said, the gray one worked for a little while as well. So I backed it off a little bit to take the pressure off. It ejected a little bit, but it hasn't come all the way out yet. I guess I'm not going to sit here and make you just watch this because that's pretty boring. I will set that aside and we'll just keep an eye on it. And this has ejected. I have some super glue. Is it on the boat? So I'm going to press this in, take this off, squirt it out, pull it back, and then cap this off again, and hopefully I can do all of that without losing too much. I don't know if you can see right there, but I have some, so do our best. So there's pin 1 right there. Ah, there. I don't know if you can see it. There's a little bevel on the ground plane right there that identifies pin 1. So if I turn this over and flip it straight like that, which corresponds with this dot. Okay, so I'm pretty confident it goes like this. So now let's apply the paste. Now, I was watching the videos and apparently it's not a huge chance that you're gonna get bridging, but I don't want to use too much paste, but I don't want to use too little either. Is that too much? Probably. Now, I'm going to try to tone this out to make sure that I A, have connections, and B, don't have... Sorry, I can't talk in place at the same time. And make sure I don't have bridges by, I'll find wherever 2 side-by-side pins are, I'll trace them out and I'll tone them side by side and see if they tone, then I know I've got a short. For the ground plane, the ground pad, that big center pad, the trick there to make sure that it's connected is after you've soldered it in, there's a tiny little exposed pin on the side, one of these 4 corners, that you put your probe there and you put it to somewhere else that's ground on the board, and if it tones, you know that pad has a good connection. I've got this set to 320, and I've increased to the largest tip so that the air is more broadly spread out. I'm going to start high and come in down slowly, and I want to heat it up evenly without the air blowing it around. So the air is currently set to its lowest possible setting. I'm going to do this very slowly. I'm not going to try to hold this in place. I'm just going to have this here in case it starts to blow away. Coming from very far up to try to just slowly, gently heat everything up. There it goes. Get some more heat into it. Okay. Is that connected? I don't know. I don't know if you can see on the DJI, but I think I got a bridge right there. Switch over to this, still with the chisel tip, and see if I can drag the solder off. This is now the non-rosin core solder, which is not what I was using last time. And all I'm doing here right now is wetting it so that it'll help suck up the extra solder. Okay, I think that's good on that side. Sorry, DJI, I might pull you out of the way. Okay, those all look okay. One on the far side there looks a bit not great. Okay, that wasn't horrible. Does it work? I don't know. Maybe it's horrible because it doesn't work and I'm going to be fighting for the next half an hour to get this to work, but let's tone it out and find out together. I'm not going to show the entire process of toning it out. You saw what I was doing last time. I'm just going to show how it's slightly different for the QFN part. Part of me thinks that looks horrible, and part of me thinks, you know what, that's not bad for my first try. Board I2C is pin 1. I'm probably highlighting it on screen. And it goes to R3. That's a good sign. And the next one is USART TX, which goes to U2 pin 11, which is over here, is the third one in. Oh, that's not a good sign. One pin worked, one pin didn't. Lovely, that's off to a great start. Is this just not sharp enough? Do I have to take a file to it and file the end off? Oh, I have an idea. Okay, tip wasn't fine enough. Okay, so that's pin 2 is working. Now, to make sure there's not a short, I'll do 3. Okay, no short. The third one is not used. The fourth one is 3.3. 3.3 is this one right here. I need a 3.3 for my right hand. Okay, boot is 3.3. Okay, and what's next to 3.3? Ground is right here. Okay, no connection. I'm just going to keep doing that for the rest of the pins, checking each pin and then checking the pins on either side to make sure that there's no bridges, and I'll bring you back when I'm done. Happy testing noises. It worked! Everything's there and I don't see any shorts. I don't know if I'm going to be able to show you where that tiny little pin is. I'm going to try to take a picture because this seems to take better pictures than these camera do. That's from Fine English. And I'll put it right here. I'll try to put a little arrow showing the tiny, tiny tiny little thing in the corner, which is the pin for the ground. So what I did was, you can see here, I just have this clipped off to the ground test point. Oh, I don't know if you can see this, but at the end of this wire, I cut it at an angle so it goes to a really fine point. On the right-hand corner of this picture, I've got an arrow pointing to it. You'll see just a tiny little bit of metal sticking out. That is connected to the ground plane on the underneath of the chip, and it toned out as well. So now what I'm going to do is I'm going to start adding some of the larger components. I need to get a minimum set of components on in order to actually program the MCU and see if it's working. So I think I'm going to put the capacitors and the resistors and whatever's needed for the MCU installed, and then whatever's needed for the programmer header and the RS-232. So I can hopefully plug in a serial adapter and the programming header, program it, and have it just print hello world to the serial port, and then I know if it gets to that far, the MCU is working if nothing else. If that works, I will then put on probably the parts for the first relay, so I can actually test switching the relay, and that will require putting on the parts for the IS31FL3731, their LED driver, so that I can drive the LEDs for that first relay as well. And that should be a good little basic, it's a live test, assuming it is. So for me, I've got a bunch of soldering ahead of me. For you, I'm just finishing up and I thought I would show you what I've done so far. So I can't find this. I know I bought it, but I don't know where it is. I realized I had to do the Enemy A2000 right now because that's what's going to provide power to the board. Even though I might only just use that pigtail with the voltage applied, point is, power has to come from here. I still have to do some of the supporting components around the various voltage regulation. I got the DB9 serial connector on. I've got the programming header on, boot reset. I've got most of the hardware around the IS31, the MCU. The memory cards are not that important right now, but I had them here, so I might as well put them in. I'm not ready to start bringing the board up yet. I've got some missing parts, but it's coming along. It's coming along. I think if I've come this far, I might as well put one relay diode and a couple connectors and the LEDs in. That way, if I have a problem with the serial port, I can try turning on the lights, and if the light comes on, I know it's a problem with the serial port. If the serial port doesn't come on, and I don't have any other way of testing it, I don't know if it's the serial port or the MCU, etc. But yeah, making progress. So I ended up just populating all of the passives. I still need to put these 3 ICs in, but trying to figure out which passives were for which parts, considering how cheap these passives are, I decided screw it, I'm just going to fully populate it. If I really get tight and this board is garbage, I can pop these off later. But one of the problems I realized, that is going to leave these LEDs far too low. I want them to be the tallest thing here so that when I build the case, the LEDs are right at the surface. So I am going to do a 3D print, I have to design it still, that goes in between the bottom of the LED and the top of the PCB so that I have a consistent height set when I solder all of these in. Really don't like that at all, but it should carry the current. I think I am going to now solder on these parts, and then tomorrow I will set up the camera and we will see if we can talk to it. So I've been making some good progress. Oh, hello, May. Say hi. There's a very good chance that when I fire this up, something's going to go pop. Now, a patron of mine a couple years ago very generously gave me a bench power supply so I can do current limiting. So I can, when I do bring it up, I'm going to plug in the 12 volt NMEA 2000 cable, and so I'll set the voltage to 12 volt and I'll set the current to 100 milliamp. But blah, 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 I'm getting ahead of myself. I think when I talk to the camera, Miss May doesn't realize I'm talking to you guys, and she thinks maybe I'm going crazy and talking to myself. God, I love this little girl. So it took me a few tries, but I made these little standoffs that go like that so I can drop the LEDs in and keep them a consistent height. So if I get this down low, when I make the case for this, the case will have cutouts so the LEDs will stick through and the top of the case will rest against these standoffs. So that's the majority of it. One other thing in case it didn't come through in the DJI. I started using the mildly rosin activated Flux instead of the clear stuff. This works a lot better, but holy crap is it hard to clean off the boards. Like it leaves like a tacky goo. The IPA breaks it up, but I have to hit it a lot with the IPA. I need to figure out how to get the toothbrush. I don't know if I need to pour some IPA into a little bowl so I can dip the toothbrush in so I can like dip and scrape and dip and scrape. I'll figure that out at the end of it. But yeah, the first thing to solder today are the LEDs. I'm gonna try this again and see if I can make this work because this stuff leaves much less of a mess. Yes, it sizzles more, and yes, that saps heat, but if it works, well, it'll be fine. Also, I was talking to my friend when I was talking about the testing for bringing up the board, and he was saying that he uses a type of lead-free solder that has silver in it, and he thinks that would make it's not as good as leaded, but it would be better than what I'm using. It's obviously more expensive. Okay, before I start bringing this up, I have to clean this better. I've been using paper towel, which is clearly not the right thing to use, but it's what I have. All right. So several hours have gone by, I have eaten, and I am as ready as I'll ever be to power up this board. I've set the bench supply to 100 milliamp and 12 volts. It's currently on iSet, which according to the Googles, even though it says right now CV, constant voltage, apparently if it tries to go over the voltage or over the amperage, it switches into the appropriate mode. So in theory, even though this still says CV, it is actually in CC, and I've got the 100 milliamps set currently. I wanted to set up my thermal camera, but I made the horrible mistake of cleaning up and now I can't find it. Ooh, shadows. If it smokes, hopefully it makes for good YouTube. Really, really hoping it doesn't smoke. This is where all the power stuff is, so I'm gonna have you looking at this. The leads from the bench supply go to the appropriate pins on the Enemy A2000, the M12 connector. The other thing I've done is I've taped up the negative connector so that it is insulated so I don't bump the end of the alligator clips, but also if anything goes wrong, I can just pull this really quickly and cut the power. So it's kind of my e-stop as well. One of the other things I did with these test points and with these test points is I went through and I made sure, well, let me just do it right now. I will reenact. So here's ground for the ship, which connects to the lugs, which will ground it to the chassis. So right now it's on ship ground, and if I go to regular ground, there's no connection. So I know that the two grounds are isolated. If I go to voltage raw, which goes to this pin, it's connected. Going from V raw to ground, nothing, no connection. So I don't have a dead short there. So the 5-volt ship is this one here, lower pin. So that is connected. These are all just the thermal pads, which are done pretty horribly now that I look up close, but whatever. And what I'm going to do is I'm going to look at shipboard, or the isolated 5-volt, no connection. So I know the two 5-volts are isolated. Regular 5-volt, I will check against 3-volt. I will check against V raw, no connection. 3.3 volt, I don't know what else to test against. No connection to 5-volt. No connection to ground. Actually, I should probably put this into resistance mode. So I'm going to put the ground here, and I'm going to apply the positive probe to +5, and I'm going to see what looks like a short as the capacitors charge up, and then it should drop down. 15 kiloohms of resistance. But you see how it was high initially, and then it dropped down? That's the capacitors charging up and then stabilizing. If this was constantly fluctuating, or if it didn't drop down, that would be a sign, as I understand, that there was a short somewhere. So now I'm going to do the same thing too. So I've got ship ground connected. So I'm going to go to +5-volt on the ship. And it is sitting at 72 kiloohms and it's stable. So that looks good. Now I'm going to do regular ground, or isolated ground. And I'm going to do, I wasn't watching. 400 kiloohms? No, 400 ohms. That's really low. Is 400 ohms a problem? That might be too low. That might be a problem. This is on the 3.3. I'm at about a kiloohm. 0.84 kiloohm, 3.3 to ground, and 400 ohm, 5-volt to ground. Is that a problem? Do I have a diode in backwards somewhere? I'm going to stop and phone a friend and see if I can figure out if that's a problem or not. I'll be right back. All right, so I spoke to my friend Andrew, who you've seen many times in my past videos, and he confirmed that this looks good. Now, he did have a suggestion that I am going to do, and that is, initially, don't leave this connected. I'm going to turn on the output of the bench supply. I'm going to have to be watching the current draw and the voltage on the bench supply, so you're actually going to have a better view of what happens to the board than I will. But the plan is, once it's turned on, I'm just going to tap this briefly and see what happens. I mean, by the time you're watching this, it's way too late. But if you can go back in the past and cross your fingers for me, I'd be much appreciative. Plug this in. Holy fuck, I'm nervous. I expect something to go wrong, right? Just do it. Just fucking do it. Jump. Jump. All right.
Someday you're gonna look back at these videos and you're gonna be like, "Oh my god, I was so nervous."
Okay, so I touched it.
Tell me what's happening.
I touched it and it didn't smoke immediately, but
That's good. What did it say on the power supply?
I couldn't read it. Let me do it again. 0 amperage.
Well, that's not shorted then.
Could it just be drawing so little power that it's...
Don't you have a fuse?
I do have a fuse.
Did you put the fuse in the fuse holder?
It's soldered in place. It's a PTC resettable.
Oh, okay. Well, if if it's not drawing any current, just leave it connected and then start measuring with your meter. That's the next step. Start from the power input and just work your way back.
Okay,
Make sure you
so
don't have like a backwards diode or something like that.
I'm doing the VRAW, which goes through the diodes before it gets to that pin. Okay, so I've got 11.79 volts at the test point. Okay, so now the next question is, if I've still got that to ground, do I have 5 volt on the ship? 5.02. Okay, so my ship 5 volt is alive.
All right, keep going.
Okay, switching over to isolated ground to plus 5. Oh, wow. 5.001 volt on the isolated 5.
Yep, that modern electronics for you.
Oh, 3.9 on the 3.3.
Uh-oh. Are you sure you're in the right ground
Yes.
for that one?
Yes, I am. That might explain why nothing's turning on.
And you're not drawing any current?
No current. 0.00 amp.
Disconnect it for a second. Let's talk about how to check that.
Yo, there's Andrew on the phone.
Okay, let's have a look. So let's talk about your power supply. Which one is the 3.3?
There's only one 3.3, which is the third box down, second from the left.
Oh, okay. Read off the part number that you put there.
Lima Michael 1117 Michael Papa hyphen 5.0. It is U15.
What does 5.0 mean?
I
It's
think
a rhetorical question. It's a 5 volt regulator is the problem that you have on there.
What? I thought it was a 5 volt input.
No, 5.0 on the end means that's the output. So you need to dash 3.3. I'm waiting for the swear. Ready?
Because the camera's on, I'm trying very hard not to.
Here, I'll sort of. That's what I was expecting, right? Yeah, so...
I don't know. How the fuck did I make that? Oh, there's your fuck. How the fuck did I make that mistake? How did I not catch that?
Well, you've got a million parts on your very first board ever. Don't beat yourself up over it. Seriously. So, here's the reason why you're seeing 3.9 volts is because that's just a normal linear regulator. So you're basically seeing the dropout voltage.
Yeah.
Where's your STM32? Let me just search for that. I'm just going to check the absolute max on this data sheet just to make sure that you
didn't just smoke it.
Damage the micro. Oh, it's 4 volts absolute max, so you're good still.
Okay.
I would not worry about having damaged it.
Okay, so
You did not break it.
I got close to breaking the MCU, but everything else is fine. All right. Thank you, sir.
Well, have a good one. Bye.
You too. Bye-bye. So as you heard when I was talking to Andrew, I hope audio quality was decent. The problem is that I should have been regulating 5 volt down to 3 volt, and I was doing 5 volt to 5 volt, which it has a low loss, so it dropped down to 3.9 volt. So as mistakes go, it doesn't look like I damaged anything, which, considering where I am in my learning curve, I'm going to take that as a huge win. I applied power to the board, and nothing burned up. And most of the voltages were looking really good. So I'm actually pretty happy, even though it's not working right now. So I think this is a perfectly cromulent place to end this video. It's not a huge success, but it's also not a huge failure. Nothing turned into popcorn, or chipcorn? What would you call that when electric ICs let out the magic smoke? Anyway, I'm actually in a really good mood right now. It's not 100%, but I'll take it. So I'm the Digital Mermaid. Yeah, I'm very happy. See you next time. Bye. So, I have not been happy with how the DJI has been recording the PCBs. Very not great when I zoom in. No focus at all. So, I came up with a little design. I don't think it's the worst thing in the world. I can put my iPhone up here, and hopefully future videos showing the circuit boards won't be as crappy.